Okay. Greetings, this is Group 12. We're presenting our final project, which is the Snake and Ladder game by Roy Lizardo and David Montoya. The Snake and Ladder game is a pretty simple game that I believe we all know. It has pretty simple rules, which we can see right here. Players take turns rolling a dice to move their token forward by the number that appears on top of the dice. If the player lands on a square with the base of a ladder, they increase their position going up on the board, and then if a player lands on a square which there's a mouth of a snake, then the player decreases their position. Players take turns clockwise, and the game terminates until one player reaches the final square, which is square 100. Even though if a player rolls a number that counts past the final square, then the player must wait until the next turn to try again. So for example, if players in square 95, they need 5 to roll a 5 on the dice to get to the square 100. Um, and if they get a 6, they cannot move. Their position remain unchanged, and they need to wait for their next turn to get a 5. So over here we can see a flowchart of how the program runs technically. So it starts, initialize a variable and the seed random. Then it checks if the player has won or anything, and if it hasn't won, it makes it roll the dice, move the player to the new position. Then it checks if if the new position is a snake or a ladder, and then it switches the player to the new position depending if it is a snake or a ladder. Then it prints the board, it finishes, and it starts again until there's a winner. And in case there's a winner, one of the players wins, um, it's gonna start again as well. And then uh, I will be presenting the the first three functions of the program. The program is is conformed by four functions. One of them is the main. I'll be presenting the three other functions that are not the main. And the first one that we can see is the roll dice function, which the function simulates the roll of a six-sided dice by generating a random integer between 1 and 6. The random the rand function generates a pseudo random integer. Then to constrain to the specific range, we use a modulo 6 plus 1. That way the range is 1 to 6, matching the number of a dice. Pretty simple function. And then we have also the initialization of the two global variables of the program, which is player 1 and 2, which are used in different functions through the program. And then the next function, it will be the print board function. This function is responsible for visually representing the state of the game along with the player's position. It gives us an array of that is board of 101 elements, and is created to represent squares 1 to 100. Then we have a variable named alt, which is a flag to print left to right when alt is equals to 0, and right to left when alt is equals to 1. And then we have also variables iteration LR, which is iteration left to right. And then we also have variable iteration iter RL, which is iteration right to left. And these iterators are for traversing the board, which the alternation is done to mimic the zigzag numbering of a traditional snake and ladder board. Then we go into a while loop that that is the loop that technically prints the right left and left to right squares, and the loop iterates 100 times. So when printing left to right, like mentioned before, the variable out is equals to 0, which makes it the row to be printed left to right, and it decrements the variable iter LR to move backward through the array. Checks if the current position matches player 1 or 2, and prints either player 1 or player 2 on the board to indicate position. If it's not player position, it prints the square number. When reaching the end of the row, it switches to the other type of printing, that is right to left, by setting out equals to 1. And then we have the other one, the else, that is the iter RL, that works as opposite of the other type of printing that is left to right. It just increments the variable iter RL to move forward through the array, and reaching to the end of the row switches left to right printing until it gets to the last row, that's the stop condition. When reaching the last row, it breaks and exits the loop. And then we have the next function, which is move player function. The move player function is responsible for updating a player's position based on their dice roll while accounting for interactions with snakes and ladders. The function ensures the player doesn't move beyond square 100. New position is calculated by adding current position plus the roll to give the new position. The snake and ladder array is initialized with all values set to 0, where positive values, which are ladders that increase position, and negative values that are snakes that decrease position. For example, if player lands in square 6, the square 6 is a ladder, and it increases the position by 40. And then if player lands in a square 23, a square 23 is a snake, and it decreases player position by 10. Then, so after the calculation of the new position is done, the snake and ladder array is used to check if the square is a snake or ladder. If the square is a snake or ladder, its value is added to the new position to get the final new square. We use an if with the condition new square greater than 100 to ensure that the position doesn't exceed 100. And if new square is greater than 100, move is invalid. Player position remain unchanged. And then at the end, the function returns variable new square. And that will be for my part. And then my colleague Roy will continue with the next function.
Hi, I'll be going over the main function. These are all the areas that we're going to cover. As with all code, we start off by declaring and initializing our variables. We first have the sran function, which sets the starting point for generating the series of pseudo-random numbers. The sran function here is initialized with the time function. The time function returns the current time as a number of seconds since January 1st, 1970, a date known as the Unix epoch. By using the time function as a seed to srand, a different sequence of random numbers can be initialized for the dice roll each time the program is ran. Without the time function here, srand would have a static seed, and the program would fail to emulate the roll of a dice. Next, we declare the current player variable, and we initialize it to 1 since this value will be used to determine the player's turn. I'll later explain how this happens through the loop functions, and how the player number alternates at the end of each turn. Finally, we declare a 1 variable and initialize it to 0 for the primary loop condition. The title portion is pretty straightforward. It's just a print function, and here we had it set to play Let's Play Snakes and Ladders. The main loop is a while loop. This loop allows the code within it to be executed repeatedly based on a given condition. In this case, the condition used is not 1. The logical not operator inverts the truth value of its operand, meaning that it's going to return true if the operand is false. So, the condition not 1 will evaluate to true since 1 is set to 0, and this will allow the loop to continue to iterate. The prompts and function calls at the beginning of the main loop are as follows. The first one is a print function that tells the player to press enter to roll the die. Get character pauses until the player presses enter. The next part is a call of the roll die function, which returns the value of the pseudo-random dice roll. This value is then set to the variable roll, and then this variable roll is printed to the player, showing them what number they rolled. The main loop has several nested statements. First, we have an if statement with a condition of current player if current player equals 1. This calls the move player function and updates the player position variable with the function's return. And then next we have a print function that displays the player's position. And then we have another function to display the array or the board. This is done by calling the print board function. After that, we have another if statement with a condition of player 1 if player 1 equals 100, which is the last tile in the array or the board. In this case, if this is true, that means the player has won, so it prints out player 1 wins, and it turns the 1 variable into a number 1. In this case, this would stop the main loop and end the game. The next portion is exactly the same as the previous one. It's just starting with an else statement. In this case, it initiates the else statement if player 2's turn is valid. This just occurs because in the first statement, the if condition was if player 1 is set to 1. So if it's not set to 1, then it runs this else statement. Everything else here is exactly the same, except if the player 2 is equal to 100, then it shows player 2 wins. At the end here, we have the switching player code. The way this works is that it uses a ternary conditional operator, which is a shorthand for an if. It's a shorthand if-else statement in C. The part of the parentheses is the conditional expression that checks if the variable current player is equal to 1. The question mark represents the start of the ternary conditional operation. The part after the question mark and before the colon specifies what happens if the condition is true. And the part after the colon specifies what happens if the condition is false. This is how we alternate the player's turns. This is the resulting output. As you can see, we start with our title greeting, and then the program transitions to the main loop, prompting the player to press enter to initiate the dice roll. And for each turn, a new board is printed out with updated player positions. After a couple of rounds of playing, in this case here, player 2 wins. You can see them in the last array position or board position. And then we get the message, player 2 wins. And that's the end of our code. Thank you so much.